Quick question. Which has more sugar, a chocolate bar or a plain baked potato? Most people say the chocolate bar without even thinking about it. It's not close. A chocolate bar runs about 7.5 teaspoons of sugar equivalent. A baked potato, plain, no butter, no sour cream, runs about 9. The potato wins. And it's not even the worst offender on this list. Here's the uncomfortable part. Foods like rice, bread, and potatoes don't taste sweet, so your brain never files them under sugar. But your body doesn't care what your tongue thinks. It converts them into glucose just as fast, sometimes faster, than the stuff that actually tastes sweet. And because there's no sweet warning label attached, most of us eat way more of it than we'd ever allow ourselves with dessert. By the end of this video, you're going to look at a plate of rice completely differently. And there's one very specific food coming up that beat rice, and it's not even close. Let's put this in a language everyone actually understands. Sugar cubes. 1 cube is roughly 4 grams of sugar-equivalent carbohydrate, meaning regardless of whether a food started out tasting sweet or not, this is roughly what your body eventually converts it into and dumps into your bloodstream. Plain, unsweetened cereal flakes. The boring, healthy kind, not the sugary cartoon mascot stuff. About 8 cubes in a normal bowl. A baked potato? About 9. A ripe banana, genuinely one of the healthier items on this list for the record, around 6. And 150 grams of boiled white rice, a completely normal dinner portion, nothing excessive, comes in at about 10 cubes. 10. That's higher than the chocolate bar we started with. Here's a way to actually picture that. Imagine sitting down to dinner, and before you touch your rice, spooning 10 sugar cubes directly into your mouth. Nobody would do that voluntarily. It would feel absurd, maybe even a little alarming. But swap that spoon for a rice cooker, and somehow it's just dinner. None of these foods taste like dessert. None of them come with a mental warning label. But your bloodstream can't taste anything. It just sees glucose molecules arriving, and it responds exactly the same way, no matter where that glucose came from, whether it rode in on a spoonful of sugar or a forkful of rice. So if your body genuinely can't tell the difference between the two, why does it matter so much that your brain can't either? That gap between what you taste and what your body actually receives turns out to be doing damage you can't feel for years before you'd ever notice anything was wrong. Quick honesty checkpoint, because this is important. I'm not saying a potato is nutritionally the same thing as a candy bar. It's not. A potato comes with potassium, vitamin C, and fiber, especially with the skin on, none of which a chocolate bar is bringing to the table. What's actually comparable here is narrower and more specific than these foods are identical. It's the glucose load, the raw amount of sugar your bloodstream ends up processing after digestion. That one specific number can rival or beat candy. The full nutritional picture is a different, more complicated conversation, and it matters too. Here's the simplest way to picture starch. Imagine individual glucose molecules holding hands in a long chain, like a paper chain of little sugar links. That's basically what starch is. Glucose, just linked together into a bigger molecule. When you digest bread, rice, or potatoes, your digestive system breaks those handholds apart one by one, and out comes the exact same free glucose you'd get from a spoonful of table sugar. Same molecule, atom for atom, just delivered slower and without the sweet taste that would normally make you think twice about how much you're eating. That slower delivery is a real, meaningful difference, worth being fair about. Because starch has to be broken apart piece by piece, it generally reaches your bloodstream more gradually than straight table sugar does, which usually means a gentler rise in blood glucose rather than a sharp spike. So the two aren't identical in how they hit you, just in how much glucose eventually shows up by the time your body's done processing it. Now, your body only has a limited amount of glucose it can actually burn for energy right away, enough to fuel your muscles, your brain, whatever you're doing in that moment. Whatever's left over doesn't just vanish. It gets converted into fat and stored, largely in your liver, because your body considers that the safest place to stash it. Safer, biologically speaking, than letting excess sugar keep circulating and damaging the delicate lining of your blood vessels. Do that consistently, meal after meal, year after year, plate of rice after plate of rice, and your liver slowly, quietly becomes coated in fat. Picture a healthy liver, deep reddish-brown, smooth, the color of a fresh cut of liver you might actually recognize from biology class. Now picture a fat-infiltrated liver, pale, almost yellowish, visibly swollen. Same organ, completely different appearance, built up one unnoticed glucose surplus at a time. And here's the part that makes this genuinely sneaky. A fatty liver becomes progressively less responsive to insulin, the hormone that normally tells your cells to absorb glucose from your blood. Less responsive means your pancreas has to work harder, pumping out more and more insulin just to get the same job done. It's a slow, completely symptomless spiral that can run for roughly a decade, a full 10 years, before it ever shows up officially as prediabetes or full type 2 diabetes. Completely silent the entire time, which raises a pretty unsettling question. How many people are walking around right now with this already happening inside them, with zero idea? The answer is a lot more than you'd guess, and even doctors, the people trained specifically to catch this, aren't immune to missing it. Here's a story that puts this in perspective. A physician with decades of clinical experience, someone who'd spent an entire career treating patients, ordering labs, managing chronic disease, didn't personally connect the dots that bread, rice, and cereal function as sugar inside the body. Not until a patient bluntly told him so, pointing out that this was, in her words, schoolboy biology, he really should have already known. Think about that for a second. If a career doctor missed this basic connection, it's a pretty safe bet most of us have too. This isn't some obscure, cutting-edge research buried in a journal nobody reads. It's fairly simple chemistry that somehow just doesn't make it into how we talk about healthy food at the dinner table, or on nutrition labels, or in doctors' offices during a routine checkup. And that silence has real consequences at scale, not just for individuals. About a third of people worldwide living with type 2 diabetes don't know they have it. They're walking around undiagnosed, sometimes for years. Every single year of poorly controlled type 2 diabetes costs roughly 100 days of life expectancy. Think about that trade for a second. About 3 months of your life, quietly spent, for every year the condition goes unmanaged. And fatty liver disease, the exact mechanism we just walked through, is present in roughly a third of people in developed countries, often silently, for up to a decade before anyone catches it on a scan. Type 2 diabetes used to be called maturity-onset diabetes because it essentially never showed up in anyone under 55. The name itself assumed it was a disease of aging. It's now being diagnosed in children, actual children, in elementary school, with a condition that used to be considered exclusively a problem for retirees. So what changed in just a few decades to shift that so dramatically? Diet is the obvious headline answer, but the specifics of exactly where all this sugar is hiding, especially in foods we've been told are the safe choice, might genuinely surprise you. Rice, bread, and potatoes are really just the beginning of this. A few more foods worth a second, more skeptical look. Fruit juice delivers a fast, sharp glucose spike because stripping out the fiber from whole fruit speeds up absorption dramatically. Your body handles a whole orange very differently than it handles that same orange, blended, strained, and poured into a glass. The fiber in the whole fruit acts like a natural speed bump that juice simply doesn't have anymore. Dried fruit snacks can run 60 to 70% sugar by weight, while being marketed and genuinely perceived by most shoppers as a healthy snack option, purely because the word fruit happens to be sitting right there on the front of the package. Dried mango, for instance, is often closer in sugar density to actual candy than to the fresh fruit it came from. White chocolate sits at close to 80% sugar by composition, arguably the most honestly named junk food on this entire list, and still one of the most consistently underestimated, probably because it doesn't carry the word candy anywhere on the wrapper. And a single loaf of bread can carry the equivalent of roughly a dozen sugar cubes spread across the whole loaf. And that's before you even account for how the wheat starch itself continues converting into sugar throughout digestion, well after you've finished the sandwich. None of this means carbs as a category are some kind of enemy. Plenty of them come packaged with fiber, vitamins, and real measurable benefits. Whole fruit, legumes, and many whole grains behave very differently in your body than their refined, stripped-down cousins do. But if the actual goal is knowing what you're eating, there's a much better place to look on the label than the spot most people habitually check. Here's a practical rule worth genuinely adopting. Total carbohydrate content on a nutrition label matters more than just the added sugars line by itself. Starchy carbs convert to glucose, regardless of whether sugar was technically added during manufacturing. Your body doesn't care about that legal distinction, so realistically, your grocery store habits shouldn't either. And here's a simple, completely free at-home self-check that doesn't require a lab, an app, or a doctor's visit. Take a piece of string, cut it to your exact height, then fold it in half. Wrap that folded string around your waist at its widest point. If it comfortably wraps all the way around, you're generally sitting in a lower risk range. If it doesn't quite make it around, that's a rough, practical, well-studied signal of visceral fat and metabolic risk worth paying real attention to. The same kind of fat we've been talking about quietly building up in and around your liver this entire video. So the next time someone proudly tells you they're off sugar because they cut out soda and dessert, while still eating rice, bread, and potatoes at basically every single meal, you'll know that's not quite the win they think it is. The chemistry in your bloodstream doesn't care what something tastes like on the way in. It only cares what it eventually turns into. If this changed how you're going to look at your next plate of rice, subscribe. I break down what the science actually says. No fluff, no fear-mongering.